Hydrocarbons. These are structures that contain only carbon and hydrogen atoms. There's three parts to it. There's the root. It's the really important part. This is the part you do first. And this is how many carbons are in the longest continuous carbon chain. And here I've included a table of the first 10 root words for carbon chains. And this is going to be the same for all organic compounds. So this is really something you need to memorize. You change the ending, the suffix, depending on the type of hydrocarbon that you have. And then there's a prefix sometimes, and that indicates any side carbon chain groups. And the position, the prefix position, is the numbered carbon where that side group is. The order in the name is prefix, then root, then suffix. Okay, alkanes. These are carbon atoms joined together by single bonds. These are considered to be saturated because each carbon is bonded to the maximum number of different atoms. So each carbon has 4 bonds and none of them go to the same atom. Alkenes. These are carbon chains containing at least one double bond between 2 adjacent carbons. These are considered unsaturated because there is 2 bonds between 2 atoms. So it's not bonded to the maximum number of different atoms. So these are unsaturated. It still makes 4 bonds. It's just that there's 2 between 2 carbons. This carbon-carbon double bond in an alkene does not allow rotation. So the carbon can twist back and forth, but it cannot go all the way around in a circle like it can for an alkane. Alkynes, carbon chains containing at least one triple bond between 2 adjacent carbons. It is also unsaturated. So you've got 3 bonds between 2 carbons, which means you only have room for 1 more atom. So that is also considered unsaturated because carbon is not bonded to a maximum number of 4 different atoms. Cyclic compounds contain a ring structure. So sometimes we draw these showing all their atoms. These are bad H's. Okay, so we can draw a cyclic structure like that. It makes a ring. Or we can do a line structure and you just show the carbon bonds. You don't actually draw in the carbon. The carbons are considered to be at every bend or corner, and it's considered to be saturated to the point that that structure can have. So it's understood that each of these carbons would contain 2 hydrogens. So you can draw cyclic compounds either way. This way is generally preferred because it's neater. Aromatics. Aromatics are all based on the benzene structure, and the benzene structure is best represented like that. It can also be represented like this, or like this. It is C6H6. So all aromatic compounds contain a benzene structure. So these are compounds that only contain carbon and hydrogen, and the previous 3 categories, alkanes, alkenes, and alkynes, are all considered to be aliphatic because they are basically straight chains. Both cyclic and aromatics contain a ring structure, so aliphatic are straight chains. When we get to naming compounds, the suffix part of each name is going to come from the name of the functional group or the category of compounds. So all alkanes will end in ane. All alkenes will end in ene, and all alkynes are going to end in yne. So if you have a 3-carbon alkane, 3-carbon alkane, it's an alkane because it's saturated, it's got single bonds, just carbon and hydrogen. And you look up the root in the table. 3 carbons is prop, so this is propane. And we'll get into naming in each individual category shortly.